So first we have to create the robot, of course, and by doing this, one of the properties within the main code is to call upon the treasure map class, which is where all of the functions are stored. And we are going to begin the game, and it tells us to create the map first. So first, by doing this, the obstacles are made inside of the occupancy grid. And now the robot just goes through one by one and draws each of the 4 islands. And then it also draws a kind of home position with small borders on each side. Now it tells us to choose a destination, so let's choose Island 2 and PRM. And now we are ready to calculate the path. All of this is sped up by 3 times, by the way, so that the plotting wouldn't take too long. And now we are going to Island 2, which is in the top right, following the PRM algorithm and linear interpolation. The treasure was not found, so we can move on to the next turn. But before that, I want to show this same path but with a different interpolation type. So I cleared the plot and reinitialized the robot, but it still stored the same PRM algorithm that we ran. So now we're going to show it with LSPB, and as you can see, segment by segment, in the beginning the points are closer together, and then in the middle of each segment they're spaced more evenly apart. So because the treasure wasn't found, we want to move on to the next move of the game. I just reran the PRM since I clicked go home in order to show the previous path better, but that changed the last location since it retains where it was last. So that's why there's a new path there. But this time we're choosing Island 4 with D star. And now it animates the path calculation, and now it will show the path. And now the robot takes that as its input and goes along to reach Island 4. The treasure was not found here either, so now it's time for a new turn, and this time we're going to go across to Island 3 using D star again. So the treasure was found, and that ends the game. I wanted to show another path as an example since we didn't go to Island 1 and just use PRM again, but this time with T-poly interpolation method since we didn't use that in the game. So here the path is generated. It's quite choppy, so I wanted to rerun it since every time it generates new random nodes. And I think this one's much smoother, so we're going to go with that, and using T-poly, which is our quintic polynomial method that generates a smooth acceleration profile. And now we're going to go across the board to Island 4 using D star, and this time I wanted to show D star with LSPB to show how it doesn't visibly change. So the points still look very evenly spaced because of the fact that the line segments between points is so small, since they're created much closer together in comparison with PRM, which only makes a few points that are much further apart. And so there's not enough time to see how the acceleration would change between those 2 points, and that's why they still look evenly spaced.